Have you ever looked at the night sky and thought, all these stars, do they live forever? The answer is shocking. No. Every single star you see will one day die. Even our own sun, the star that gives us light and life, has an ending. In this video, I want you to imagine something with me. Imagine the sky suddenly becoming brighter than you have ever seen before. Brighter than a full moon. So bright that even in the middle of the day, you can see a new star in the sky. That is not a normal star. That is a dying star. That is a star exploding. When a star dies, it is not always a quiet, peaceful ending. Sometimes it is the most violent, powerful event in the universe. But why does a star die? What really happens in its last moments? And what will happen when our sun dies? Let's start from the beginning, but don't worry. I will explain everything in a simple way. A star is not a solid rock like Earth. It is a huge ball of very hot gas, mostly hydrogen. Inside the center of the star, the temperature and pressure are so high that hydrogen atoms are pushed together and combine to form helium. This process is called nuclear fusion. Fusion releases an enormous amount of energy. That energy is what makes the star shine. So, inside a star, two big forces are always fighting each other. First, there is gravity. Gravity is always trying to pull everything inward, trying to crush the star into a smaller and smaller ball. Second, there is pressure from nuclear fusion. When hydrogen turns into helium, it releases energy. This energy pushes outward like a powerful explosion happening all the time inside the star. As long as these two forces are balanced, gravity pulling in, fusion pushing out, the star is stable. It shines happily for millions or even billions of years. But this balance will not last forever. One day, the star will start to run out of fuel. Let's talk about our sun first, because it is the star we know best. Right now, our sun is in the middle of its life. It is about 4.6 billion years old, and it still has enough hydrogen in its core to keep shining for around 5 billion more years. But what happens after that? When the sun starts to run out of hydrogen in its core, fusion will slow down. That means the pressure pushing outward becomes weaker. Gravity wins this fight and starts to squeeze the core of the sun. As the core gets smaller and hotter, something interesting happens. The outer layers of the sun begin to expand. The sun will grow bigger and bigger until it becomes a red giant. In this phase, our calm yellow sun will turn into a monster. It will grow so large that it may swallow Mercury and Venus. Many scientists think it might even reach the orbit of Earth. Imagine looking at the sky and seeing a huge red burning ball filling almost everything. Earth, if it's still there, will be a hot, dead world. Inside the red giant, the core is now hot enough to start fusing helium into heavier elements like carbon and oxygen. But this phase doesn't last as long as the hydrogen burning phase. After some time, the sun will lose its outer layers. Those layers will slowly drift away into space, forming a beautiful, glowing cloud of gas. This is called a planetary nebula. Despite the name, it has nothing to do with planets. It is just a colorful cloud around the dying star. At the center of this cloud, what remains of our sun will be a very small, very dense object called a white dwarf. A white dwarf is about the size of Earth, but it has the mass of a star. A teaspoon of white dwarf material would be incredibly heavy. The white dwarf no longer produces energy through fusion. It just slowly cools down and fades over billions and billions of years. So for a star like our sun, death is not an explosion. It is more like a slow transformation, from a shining yellow star to a red giant to a white dwarf surrounded by a beautiful nebula. But what about stars that are much bigger than our sun? This is where things become really dramatic. Big stars live fast and die young. Because they are so massive, the pressure and temperature in their cores are much higher. They burn their fuel much faster. A star that is, for example, 10 times more massive than the sun might live only a few million years. That sounds long to us, but in the life of a star, that is very short. Just like the sun, a massive star first burns hydrogen into helium. When the hydrogen in the core is gone, It starts burning helium into carbon and oxygen, but it doesn't stop there. The star continues to fuse heavier and heavier elements. Carbon into neon, neon into magnesium, magnesium into silicon, and silicon into iron. Inside a very massive star, the core becomes like an onion with many layers. Each layer is fusing a different element. Hydrogen on the outside, then helium, then carbon, and so on until iron is in the center. But then something very important happens. Iron is different. Fusing iron does not give energy. Instead, it takes energy. This means that when the core of the star becomes mostly iron, fusion stops helping. No more strong outward pressure. And without that pressure, gravity finally wins completely. The iron core collapses in a fraction of a second. The center of the star falls inward incredibly fast. Temperatures and pressures become extreme. Then, like a rubber ball that hits the ground and bounces back, the collapsing core suddenly stiffens and pushes outward. This creates a massive shock wave. The outer layers of the star are blown away in an enormous explosion. This is called a supernova. A supernova is one of the most powerful events in the universe. For a short time, one exploding star can shine brighter than an entire galaxy of billions of stars. If a supernova happened close to Earth, it would be dangerous, even deadly. Thankfully, there are no stars near us that are likely to explode soon. What is left behind after this huge explosion? That depends on how massive the original star was. If the star was big, but not extremely big, the core that remains will turn into a neutron star. A neutron star is something almost impossible to imagine. It is only about 20 kilometers wide, about the size of a city, but it has more mass than our sun. A teaspoon from a neutron star would weigh millions or even billions of tons. The gravity on a neutron star is so strong that if you drop something from just 1 meter, it would hit the surface at incredible speed. Some neutron stars spin very fast and shoot beams of radiation from their poles. If those beams sweep past Earth, we see them as regular pulses of light. These are called pulsars. But if the original star was extremely massive, even a neutron star is not enough. In that case, gravity crushes the core even further, and it becomes something even more mysterious, a black hole. A black hole is a place where gravity is so strong that not even light can escape. We cannot see a black hole directly, but we can see its effects. How it pulls nearby stars, how it twists space and time, and how it sometimes creates powerful jets of energy. So, when a very massive star dies, its final gift to the universe can be a black hole. Now, here is something beautiful to think about. When a star explodes in a supernova, it does more than just die. It creates and spreads heavy elements into space: gold, silver, iron, oxygen, carbon, and many more. These elements mix with clouds of gas and dust. Later, new stars and new planets form from this material. Our own solar system, including Earth, was formed from the remains of older stars. The iron in your blood, the calcium in your bones, the gold in your jewelry, all of it was made inside stars that lived and died long before our sun was born. So when we say we are made of stardust, this is not just poetry. It is scientifically true. You are literally made from the ashes of dead stars. Let's come back to our sun for a moment. Will our sun explode as a supernova? No, it is not massive enough. Our sun will end as a red giant, then a white dwarf surrounded by a cloud of glowing gas. That might sound less dramatic than an explosion, but it is still a beautiful ending. The important thing to remember is this: stars are not just lights in the sky. They are born, they live, and they die. Their deaths create the building blocks of new worlds, and even of life itself. The death of a star is not only an ending, it is also a beginning. So the next time you look at the night sky, try to see more than just tiny lights. Some of those stars are young, some are in the middle of their lives. Some are already dying inside, quietly preparing for their final act. Maybe somewhere out there right now, a massive star has just exploded as a supernova, creating the elements that will one day form new planets, new oceans, and maybe even new life. From the quiet fading of a white dwarf to the powerful blast of a supernova, to the mysterious pull of a black hole, this is what happens when a star dies. And in a way, their death is the reason we are here to ask the question. Thank you for watching. If you enjoyed this journey through the cosmos, don't forget to like, subscribe, and hit that notification bell for more space explorations.